You say this was calling what in English? These people doing that bad things. You have for me. Yeah.
Si scuola Adela. No.
Okay, good evening. Assalamu alaikum wa rahmatullah. I will start now. Please, I hope there will be no noise, so I will not be obligated to mute all of you, okay? I think there is only 14 participants and not all of you are attending. Do you hear me? Do you hear me?
Yes, doctor, we do hear
Yes,
you.
I'm going to start now, okay? I'm going to start.
Okay.
Today we will complete the topic of gluconeogenesis. I will make revision for 2 slides only. If you do not study gluconeogenesis, you will not be able to understand regulation, because regulation depends on your studying of gluconeogenesis, and you should have understand gluconeogenesis. Okay? Again, I will revise 2 slides only. In gluconeogenesis, the body sensitizes glucose from non-carbohydrates, mainly from body proteins, from the tissue proteins, and to a less extent from the stored lipids, from fatty acids and glycerol, to a less extent, but mostly more than 90% from the tissue proteins. The process depends mainly upon reversal of glycolysis. As you see, these are the irreversible enzymes of glycolysis. Okay, I will make a slide share because it's much easier to use a slide share. These are the irreversible enzymes of glycolysis. Glucokinase, of course, you should study glycolysis. Phosphofructokinase 1, pyruvate kinase. The 3 irreversible enzymes of glycolysis, you have to study them perfectly. In order to reverse glycolysis, what is meaning by reversal of glycolysis? We will start from the last enzyme, from the product of the last enzyme, which is pyruvic acid, and then we return back to the previous reaction until we sensitize glucose. Again, the product of the 10th enzyme, of the last enzyme, we reverse the reaction to the 9th enzyme, and then we reverse to the 8th enzyme until we reach the first enzyme to reverse the reaction of the first enzyme to sensitize glucose from pyruvic. So if we have any intermediate, do you hear me? Do you hear me perfectly? Please.
No, there is a bit interruption of network, doctor.
Okay, I will connect to the network of the mobile, okay?
Okay.
Okay. Again, do you hear me perfectly? Do you hear me?
Yeah.
Okay.
Yes, doctor. It is not
Gluconeogenesis to sensitize glucose from non-carbohydrates, mainly from the tissue proteins. The body should get glucose by breaking down its own tissue protein, which is the muscle protein. Why the body makes glucose? This occurs during fasting or starvation for a long time. When a person stops feeding for several days, there will be no glucose in the diet, no sources of glucose, so the body breaks down the muscle protein to sensitize glucose. The body also breaks down the lipids, which contain fatty acids and glycerol, to make glucose, but this to a lesser extent, mainly from the proteins. The process depends entirely on the reversal of glycolysis. Of course, you should have studied glycolysis. In glycolysis, we start the first enzyme by glucose, and then we go across about 10 reactions until we reach pyruvic acid. By going in the reverse direction, in the opposite direction, if we start from pyruvic and then we go opposite direction to return back to the first enzyme, we can sensitize glucose from pyruvic. Also, we can sensitize glucose from any intermediate compounds of glycolysis. If we have any intermediate molecules inside the middle steps of glycolysis, we can reverse glycolysis and sensitize glucose. To reverse glycolysis, there is 3 irreversible reactions, which are glucokinase, phosphofructokinase, pyruvate kinase. You should study perfectly this enzyme. To reverse glucokinase, we should have gluconeogenesis enzymes, key enzymes. To reverse glucokinase, the body sensitizes glucose 6-phosphatase enzyme. This means that this enzyme is not present normally in our body. Not present normally in the cell. It is sensitized during fasting to reverse glucokinase. So glucose 6-phosphatase is a key enzyme of gluconeogenesis. To reverse phosphofructokinase, the body sensitizes another enzyme, fructose 1,6-biphosphatase. Okay? To reverse pyruvate kinase, we need 2 enzymes. This step is difficult. To reverse pyruvate kinase, the body sensitizes 2 enzymes to reverse this reaction. Pyruvate carboxylase and phosphoenol. I will divide the name of the enzyme. Split phospho, we get capital P. The name of the enzyme, we get capital E. Please, I don't need noise. Pyruvate, we get capital P. Carboxykinase, it is written as CK. So this name of the enzyme is abbreviated. PEPCK. Phospho means phosphoric acid. En means double bond. All hydroxyl. Pyruvic, capital P, pyruvic acid. Carboxykinase, we get C and K. So to reverse pyruvate kinase, we need two enzymes, pyruvate carboxylase and phosphoenol pyruvate carboxykinase. You should know the abbreviation, PEPCK. Is my voice clear for you?
Yes, doctor.
Okay.
Yeah.
I will repeat the slide. This slide, I discussed this slide last Zoom meeting, but I will repeat to understand regulation. For all amino acids are glucogenic amino acids, which gives glucose, can give us any intermediate molecule in the citric acid cycle. Any molecule in the citric acid cycle, certain amino acids gives the molecules of the citric acid cycle by catabolism during starvation. Some amino acid can give us alpha ketoglutarate, which is glutamic acid. Some amino acid give us succinic. Some amino acid give us oxaloacetic. Some amino acids give us pyruvic, and so on. Okay? If we reach any intermediate molecule inside the middle of the citric acid cycle, we can go through the citric acid cycle until we reach malic acid, which is malate. Malate is one of the intermediate molecule of the citric acid cycle. Okay? Here we are inside the mitochondria. Here we are inside the mitochondria. Okay? Malate must go outside the mitochondria. Must be translocated from the mitochondria to the cytosol. This is the cytosol, which is colored blue. Malate cross the mitochondrial membrane to go outside to the cytosol. And then we have another enzyme, which is also found in the citric acid cycle, called malate dehydrogenase. This enzyme removes hydrogen from malic acid, from malate, to sensitize oxaloacetate. If you study citric acid cycle, you will find that this is the last reaction of the citric acid cycle, to remove hydrogen from malate and sensitize oxaloacetate. In the cytosol, we have the enzyme which has a long name, P-phospho-en, we get capital E. Enol pyruvate, we get another phosphoric acid, pyruvic acid, carboxykinase CK. So this enzyme has abbreviation. You have to know the full name and you have to know the abbreviation of the enzyme. PEPCK, phosphoenol pyruvate carboxykinase. What does this enzyme do? This enzyme converts oxaloacetic acid into PEP, phosphoenol pyruvic acid. Phosphoenol pyruvic acid, which is PEP, this is an intermediate molecule inside glycolysis. When I reach glycolysis, I can reverse glycolysis and go in the opposite directions of the enzymes to sensitize glucose. This enzyme makes decarboxylation and utilizes guanosine triphosphate. Okay? Do you understand how amino acid is converted to glucose? Is it clear for you? You understand how amino acid is converted to glucose?
Repeat.
I will repeat again.
Yes.
All glucogenic amino acids can give us intermediate molecules of the citric acid cycle, such as alpha ketoglutarate or succinic acid or fumaric or malic or oxaloacetic. Okay, in your book, the name of the amino acids which gives these molecules of the citric acid cycle is written in amino acid metabolism. Okay? if you reach any intermediate molecule of the citric acid cycle, you can reach malic acid. This is malic acid or malate. Malate can cross the mitochondrial membrane and go translocation outside to the cytosol. In the cytosol, malic acid, which is derived from amino acids. As I said, amino acid give me molecule of citric acid cycle. And then the citric acid cycle go on until we reach malic acid. Malic acid in the cytosol is subjected to a reaction which is dehydrogenase, removal of hydrogen. And then malate is converted into oxaloacetate. Oxaloacetate in the cytosol is subjected to another reaction, which is the enzyme phosphoenol pyruvate carboxykinase, which has the long name PEPCK. This enzyme converts oxaloacetic into phosphoenol pyruvic acid, which is PEP. Phosphoenol pyruvic is a molecule inside glycolysis. By reversal, reversal means to go in the opposite direction of glycolysis. We can convert pyruvic acid into glucose, so the body can sensitize glucose from amino acids. Another mechanism, some amino acid can give me pyruvic. Pyruvic acid is an organic acid. Pyruvic can cross, this is the inner mitochondrial membrane, can cross the membrane, is allowed to cross. And then pyruvic go inside the mitochondria by an enzyme called carboxylase. Carboxylase binds carbon dioxide to any organic molecule. Carboxylase needs biotin, which is a member of vitamin B complex and needs magnesium. Binding carbon dioxide to pyruvic, we can sensitize oxaloacetic acid. Okay? Binding carbon dioxide to pyruvic, we can sensitize oxaloacetic acid. Oxaloacetic acid is not allowed to cross the mitochondrial membrane, cannot cross the mitochondrial membrane. But malic acid can cross the mitochondrial membrane. Oxaloacetic acid, by dehydrogenase reaction, can accept 2 hydrogen atom, and then oxaloacetic is converted into malic. If you notice that malate dehydrogenase is found inside the mitochondria, and malate dehydrogenase is found in the cytosol. So the enzyme works inside the mitochondria and works in the cytosol. And then malate repeats the cycle until we reach glucose. Okay? Again, pyruvic acid is derived from certain amino acids, from proteins. Pyruvic acid is translocated inside the mitochondria. And then we bind carbon dioxide to pyruvic acid by carboxylase. Carboxylase enzyme. Pyruvic is converted into oxaloacetic acid. Oxaloacetic acid is not allowed to cross the mitochondrial membrane. It will receive hydrogen atom by the enzyme malate dehydrogenase. When we add hydrogen atom to oxaloacetate, it is converted to malate. And then malate go outside, cross the mitochondrial membrane, and go to the cytosol. By reversal of the reaction, malate is converted to oxaloacetate by removal of hydrogen atom, and then oxaloacetate by the long enzyme PEPCK is converted to PEP, phosphoenol pyruvic acid, which is an intermediate molecule of glycolysis. By reversal of glycolysis, we can sensitize glucose. Is everything clear? Is it clear?
Yes.
Yes, okay.
Understood.
As a shared window close. Okay, I will share again because I go outside the, okay. Today we will speak about regulation of gluconeogenesis. Of course, you understand that gluconeogenesis has key enzymes. you have to study the name of the key enzymes. I need to ask you, does gluconeogenesis occur after feeding or during starvation? When does gluconeogenesis occur? After feeding, after we take carbohydrate in the food, or during starvation?
It's during the starvation.
Okay, gluconeogenesis needs anti-insulin hormone. During starvation, we don't have insulin. There is no insulin hormone. Gluconeogenesis depends on the anti-insulin hormones, which are mainly glucagon and epinephrine or adrenaline. Okay, what does glucagon and adrenaline do? They sensitize enzymes of gluconeogenesis. There are 4 enzymes which reverse glycolysis. These enzymes are not present normally in our body. They are sensitized during the starvation by the anti-insulin hormone. So gluconeogenesis is not a usual situation, does not occur in our body under normal condition. This is a stress condition. The first signal, that there is starvation is fatty acid elevation in the blood and fatty acid oxidation. During starvation, fatty acids are liberated from the adipose tissue by lipolysis, breaking down of the lipids in the adipose tissue. Fatty acid is a signal that there is starvation in the body. Fatty acid oxidation leads to the production of a large number of adenosine triphosphate. If you study glycolysis or citric acid cycle, you find that elevated level of adenosine triphosphate leads to inhibition of glucose oxidation, leads to inhibition of glycolysis and citric acid cycle. Because if I have high level of adenosine triphosphate, this means that the body does not need energy. So there is inhibition of the key enzymes of glycolysis, such as phosphofructokinase 1, inhibition of glucose oxidation in all the body except red blood cells. The enzymes are not inhibited because the red blood cells depends on glucose mainly, and also the brain, the enzymes are not inhibited. Again, fatty acid oxidation occur during starvation. Elevated level of fatty acid results from release of fatty acid from adipose tissue by the anti-insulin hormone. High level of fatty acid lead to the production of high level of adenosine triphosphate, which inhibits the key enzymes of glycolysis, such as phosphofructokinase 1, pyruvate kinase, another enzyme which is not found in glycolysis but works in glucose oxidation, which is pyruvate dehydrogenase complex. So, fatty acid oxidation inhibits glucose oxidation to spare glucose for the brain and the RBCs. Is this clear? Is everything clear? Please answer me. Please, do you hear me?
Yes.
Yes, okay. Fatty acid oxidation lead to liberation of acetyl-CoA because beta oxidation of fatty acid generates excess amount of acetyl-CoA, which is acetic acid bound to coenzyme A. Acetyl-CoA activates a key enzymes of gluconeogenesis, which is called pyruvate carboxylase enzyme. Okay? So pyruvate carboxylase is activated by excess acetyl-CoA. This means activation of gluconeogenesis. If you go back to in your study to glycolysis, you find that acetyl-CoA inhibit pyruvate dehydrogenase. This means inhibits glucose oxidation. Okay? Inhibition of glucose oxidation by inhibition of pyruvate dehydrogenase and activation of pyruvate carboxylase. This activates gluconeogenesis because pyruvate carboxylase is a key enzyme of gluconeogenesis. Is this clear? Do you understand? Again, please answer me. Do you hear me?
Yes.
Yes. Acetyl-CoA liberated from fatty acid oxidation. It is generated from fatty acid oxidation. It activates gluconeogenesis by activation of pyruvate carboxylase key enzyme, and acetyl-CoA inhibits glucose oxidation by inhibition of pyruvate dehydrogenase. Of course, glucagon is very important because glucagon and epinephrine induce the synthesis of the key enzymes of gluconeogenesis. These enzymes are not sensitized in our body unless there is glucagon and epinephrine, unless there is starvation. Availability of the gluconeogenesis substrates. What are the gluconeogenesis substrates? These are amino acids from which we sensitize glucose, and these are fatty acids which accelerate gluconeogenesis. Okay? Glucagon and epinephrine increase libations of fatty acids from adipose tissue and libations of amino acids from the body proteins. We will go across this slide because this is a regulation of the key enzyme of glycolysis, which is phosphofructokinase. If you remember, the key enzyme of glycolysis is inhibited by energy adenosine triphosphate, activated by adenosine monophosphate, which is a signal that the body needs energy. We will go rapidly because these are discussed in glycolysis. Hormonal regulation of gluconeogenesis. After carbohydrate diet or meal, insulin is liberated. Insulin increases the activity of the key enzymes of glycolysis, and insulin inhibits the activity of the key enzymes of gluconeogenesis. Again, insulin increases the activity of enzymes of glycolysis and citric acid cycle, and this means increase the rate of glucose oxidation. Insulin prevents the synthesis of the enzymes of gluconeogenesis because we don't need gluconeogenesis after carbohydrate meal. Gluconeogenesis starts during starvation, but anti-insulin hormone makes the reverse. Anti-insulin hormone are liberated during starvation. These hormones, please, I hear a noise. Glucagon, epinephrine, which is adrenaline, cortisol, growth hormone, thyroid hormone. All these are anti-insulin hormones. All these hormones inhibits glucose oxidation and increase the synthesis of the enzymes of gluconeogenesis. Glucagon is an inducer. What is meaning of inducer? Anyone know what's meaning of an inducer? Anyone know? Increase the synthesis of enzymes. Inducer increase the synthesis of enzymes of gluconeogenesis. Epinephrine accelerates lipolysis. Lipolysis liberates the free fatty acid. Please, there is a noise. I should mute all of you. There is a noise. If you don't stop the noise, I will mute you. Lipolysis liberates free fatty acid and increase fatty acid oxidation. And as I discussed, oxidation of fatty acids inhibits glucose oxidation because fatty acid oxidation is a sign that there is a starvation. Fatty acid oxidation leads to elevated level of adenosine triphosphate, which inhibits glycolysis and citric acid cycle, inhibit glucose oxidation. Fatty acid oxidation liberates acetyl-CoA, which activates gluconeogenesis and inhibits glucose oxidation. Cortisol is one of the hormones of glucocorticoid. Steroid hormone accelerates protein catabolism to break down the muscle protein to get available amino acid from which we can sensitize glucose during starvation. So it's very important to break down the tissue proteins, which are mainly muscle protein, under the effect of cortisol hormone. And this liberates amino acid from which we can sensitize glucose. Growth hormone is one of the anti-insulin hormone, accelerates enzymes which make catabolism of amino acids, gluconeogenesis enzymes such as aminotransferases, which makes metabolism of amino acids. I will go back again. Hormonal regulation, I will repeat it. Insulin inhibits gluconeogenesis because insulin is liberated after carbohydrate diet, and after feeding, we don't need to sensitize glucose from proteins because we have glucose from the diet. But anti-insulin hormones, which are glucagon, epinephrine, cortisol, thyroid hormone, and growth hormone, all are elevated levels during starvation. They are normally present in our blood, but in very low level. In very low level. But when the level is elevated by starvation, they have effects. Glucagon induce enzymes of gluconeogenesis. Epinephrine stimulate lipolysis, breakdown of the tissue lipid to liberate fatty acids. And fatty acid oxidation activates gluconeogenesis and inhibits glucose oxidation. Cortisol increases protein catabolism, breakdown of the tissue protein to get amino acids, from which we can sensitize blood glucose. Growth hormone enhance enzymes which catabolize amino acids such as aminotransferases. The last thing is the disease. It is very important to study the disease. The metabolic disease is called fructose 1,6-biphosphatase deficiency. This is a key enzyme of gluconeogenesis. If we don't have this key enzyme, there will be hypoglycemia. Why hypoglycemia? Because the body cannot sensitize glucose during starvation. Starvation starts after fasting more than 18 hours. Not 12 hours, 18 hours. From 12 to 18, the body breaks glycogen. We don't need gluconeogenesis. So, from 12 hours to 18 hours, the body breaks the store of glycogen to get glucose. But after 18 hours, all the stores of glycogen are utilized and depleted. There will be no glycogen. So the body has to start gluconeogenesis. If we don't have the key enzyme of gluconeogenesis, there will be hypoglycemia. Okay? The intermediates of glycolysis, which are glyceraldehyde 3-phosphate, dihydroxyacetone phosphate, these are intermediate molecules inside glycolysis, cannot be converted into glucose, so they will pass down across the normal pathway of glycolysis to sensitize pyruvic and lactic acid, and these are acids. The levels are elevated, and this leads to metabolic acidosis of the blood, elevations of the acids of the blood. Excess oxidation of fatty acids lead to liberation of a large concentration of acetyl-CoA, which will be shifted toward the synthesis of ketone bodies. Again, ketone bodies are organic acids, and this leads to metabolic acidosis. So, if we have deficiency of any key enzymes of gluconeogenesis, there will be hypoglycemia, metabolic acidosis, and elevation of the ketone bodies, which are called ketosis. Okay? Why we have hypoglycemia? Because the body cannot sensitize glucose from amino acids. There is deficiency of the key enzyme fructose 1,6-biphosphatase. Why we have metabolic acidosis? Because glycolysis cannot proceed in the opposite direction to sensitize glucose, but it will go downward in the normal direction to sensitize excess amount of pyruvic and lactic, and this leads to metabolic acidosis. Again, fatty acid oxidation liberate large concentration of acetyl-CoA, and this will lead to synthesis of ketone bodies. Ketone bodies are derived lipids and they are organic acid, and this leads to metabolic acidosis. Treatment, of course, avoid prolonged fasting. Avoid prolonged periods of fasting. You will find that fructose and sucrose, which contain fructose, lead to accumulation of fructose 1,6-biphosphate. And we don't have the enzyme which breaks fructose 1,6-biphosphate, so you have to avoid fructose and sucrose in your diet. Okay? Thank you for your attendance. Do you hear me? Everything clear? Please answer.
Yes, doctor. Yes, doctor.
Okay, I'm going to start digestion of lipids only, and Dr. Riham will finish lipid metabolism with you during this week. Please communicate with Dr. Riham to make an appointment to get a time, 2 lectures, every lecture 2 hours, so you can finish lipid metabolism with Dr. Riham during this week. I'm going to start with you. I'm going to start now. Lipid metabolism, lipid digestion only. Okay? It's this noise. Why there is this noise? I will start share of the lipid digestion, please. I have to mute all of you because there is noise. I don't know why this noise appeared. I think you are living beside a noise in the street. There is a noise. I don't know what is this noise. Okay? Taban, you are going to take a module which is called digestive module during your 3rd year in the Faculty of Medicine. You are now in the 1st year. In the 2nd year, you will have 2 modules of biochemistry. In the 3rd year of your study in Faculty of Medicine, you will have 2 modules also. One of them is digestive system of the gastrointestinal tract. Digestion of lipid will be discussed in the 3rd year, and we are going to explain it in abbreviated manner now. In our diet, 99% of dietary lipids are triacylglycerols, which are neutral fats. Triglycerides. Triacylglycerol are called triglycerides. Okay? These are the butter, the oils in our diet, and the normal animal fat in our diet. Stop sharing. يبين خالص. In addition to the triacylglycerol, we have also phospholipids in our diet, cholesterol in our diet, carotenoids, and what are the fat-soluble vitamins? Any one of you know what are the fat-soluble vitamins in our diet? What are the fat-soluble vitamins? Do you study the course of vitamins or nobody read it? Do you hear me?
Yes.
Yes. Have you studied fat-soluble vitamins or not yet?
I have.
What are
Don't
them?
know about the
Please
others.
enumerate them. What are their names? What are the name of fat-soluble vitamin?
Vitamin A,
Yes.
D,
Yes.
E,
Yes.
and K.
Excellent. Vitamin A, D, vitamin D, vitamin E, vitamin K. So if you don't have digestion of lipids, these vitamins will not be absorbed and their deficiency lead to certain diseases. So it's very important to make digestion of dietary lipids to facilitate absorption of lipids, which includes fat-soluble vitamins or lipid derivatives. Okay? Lipids supply us with excess energy because 1 gram of lipid give us 9.3 calories. And this is double the amount of calorie we get from glucose. So lipid give us much energy more than glucose. Lipids supply us with essential fatty acids and fat-soluble vitamins. Okay? Essential fatty acid cannot be sensitized in our body, and you are going to study in the course of metabolism their function. One of their function is the synthesis of eicosanoids. So they are very important to take lipids in our diet. We will begin by digestions of triacylglycerol. The main enzyme or the only enzyme is pancreatic lipase. Lipase from the pancreas of the gastrointestinal tract. The main digestive enzyme. We have lipase in our mouth, but this is very, very weak. It's called lingual lipase. Comes from the tongue, from our tongue inside our mouth. This is very weak. But the most powerful enzyme is pancreatic lipase. In order for lipase to work, we must undergo emulsification. What is emulsification? To make lipid water soluble. How can we make lipid water soluble? Again, if you make an experiment in your house. Get some oil in a glass, in a cup of glass cup, and put this oil. Oil is not soluble in water, okay? Make an experiment. Add some water over the oil. They are not soluble. But then add drops from soap, from the liquid soap. Of course, we have a liquid soap in the kitchen. If you add one drop from the liquid soap, oils will become soluble in water. And it will give me a white color, similar to milk. You can make these experiments at home by adding a drop of the liquid soap on the oil. Oil becomes soluble in water. So in the intestine, the body makes the same. The body solubilizes lipids and makes it soluble in water by mixing lipids with bile salts, with phospholipids, with lysophospholipids, with monoacylglycerol. These are products of digestion also. But bile are secreted from the liver. Without bile acids or bile salts, lipids cannot be digested. In order for the lipid to be digested, you need emulsification. What is emulsification? To make lipids soluble in water. Bile salts are secreted from the liver in the duodenum, in the first part of the small intestine. Emulsification increases the surface area of the lipid which are exposed to the pancreatic lipase. What do lipase do? We are going to see what do lipase do. Colipase is another enzyme, but it has a minute importance, a minimal importance. The main enzyme is the pancreatic lipase. Also, the colipase is secreted from the pancreas. How can digestion occur? We can look at the diagram. If you look at this diagram, I'm going by the mouse. Do you see the mouse? I am making a circle. This is triacylglycerol, which is called TAG, T-A-G. Triacyl glycerol contains glycerol. Glycerol is an alcohol which has 3 hydroxyl group. In the first position, this is the first fatty acid. And this is the second fatty acid. And this is the third fatty acid. All these fatty acids are esterified, makes ester bond with glycerol. But glycerol is written like this. This is glycerol. Fatty acid number 1, fatty acid number 2, fatty acid number 3. Okay? Do you see all fatty acids? FA1, FA2, FA3. 3 fatty acids are bound to glycerols. This is called triacyl. Acyl means fatty acid. Glycerol. Glycerol with 3 fatty acids. Okay? By pancreatic lipase, I'm going around lipase. Fatty acid number 3 is removed. This fatty acid is removed and replaced by hydroxyl group. Do you see the hydroxyl?
Yes.
So fatty acid number 3 is removed and we get DAG. What is DAG? Diacyl glycerol. Di means 2. Acyl means fatty acid. Glycerol, this is an alcohol. We have only 2 fatty acids here. Fatty acid number 1, fatty acid number 2. And here we don't have fatty acid. It has been removed here. Then pancreatic lipase will act again on fatty acid number 1. Fatty acid number 1 will be removed, and this is the position of fatty acid number 1. And this is the position of fatty acid number 3, replaced by hydroxyl, which is alcohol. And then we are left with fatty acid number 2. It is called MAG. What is MAG? Monoacyl glycerol. Mono means 1. Acyl, fatty acid, equal fatty acid. Glycerol, this is alcohol. There is 72% of monoacyl glycerol. What is the meaning of 72? 72 of the fat taken in our diet is metabolized to monoacyl glycerol. 72 of the concentration of the fat taken in our diet is converted to monoacyl glycerol, which has fatty acid at position number 2. This is position number 1. This is position number 2. This is position number 3. Means this is the first carbon atom. This is the first carbon atom. This is the second carbon atom. And this is the third carbon atom. You understand why this is position 1, 2, 3 according to the carbon atom. Okay? There is an isomerase enzyme. What do these isomerase do? It makes translocation of fatty acid from position number 2 to position number 1. Again, an isomerase enzyme translocate fatty acid from carbon number 2 of glycerol to carbon number 1. This is the position number 1. This is called MAG number 1. Means fatty acid attached to position number 1. MAG means monoacyl glycerol. 6% of fatty acid in our diet are converted to monoacyl glycerol. Then pancreatic lipase works again. This means that pancreatic lipase cannot act on the position number 2. So we have to translocate fatty acid from position number 2 to position number 1. And then by hydrolysis, fatty acid is liberated. And then we are left with glycerol. Please revise glycerol from carbohydrate chemistry. Glycerol is an alcohol which contains 3 hydroxyl group. It is the sugar alcohol of glyceraldehyde. We have studied glyceraldehyde in carbohydrate chemistry. 22% of triglycerides in our diet are converted into glycerol. Again, 72% of the triglycerides of the diet, of the lipids in our diet, converted to monoacyl glycerol with a fatty acid at position number 2. 6% of the fats in our diet is converted to monoacyl glycerol with fatty acid at position number 1. 22% of the fat in our diet is converted into glycerol, and please revise the structure of glycerol from carbohydrate chemistry. These are written here. the product of digestion of pancreatic lipase? You may be asked on the exam, what are the product of digestion of pancreatic lipase? 72% monoacyl glycerol, which have fatty acid at position number 2. 22% we have glycerol and free fatty acids. 6% we have monoacyl glycerol with fatty acid at position number 1. We have another thing. In our diet, we have phospholipids. And then if you study lipid chemistry, phospholipids also contain glycerol. Glycerol is a main alcohol of lipids. We have fatty acid at position number 1. Okay? We have fatty acid at position number 2. And then we have phosphoric acid and nitrogenous base. These are phospholipids. Again, phospholipids are composed, this is glycerol, composed of glycerol. We must have alcohol. Any lipids must have alcohol. The main alcohol is glycerol. We have another types of alcohol, but it's not written here. And the alcohol must form ester bond with fatty acid. Fatty acid number 1, fatty acid number 2, and that number 3, we don't have fatty acid. We have phosphoric acid and nitrogenous base. There is another enzyme from the pancreas which is called phospholipase A2. Why it is called A2? Because it acts on fatty acid at position number 2. Phospholipase A2 is an enzyme come from the pancreas, makes hydrolysis, liberates fatty acid from position number 2, and then we get lysophospholipid. Lyso means we removed fatty acid from position number 2, and instead we get the hydroxyl group of the glycerol, the alcoholic group of the glycerol. Because this makes lysis of the RBCs if its level is high. But of course, this is not present in the RBCs. This is present in the intestine because digestion occurs inside the lumen of the intestine. Another thing we get from our diet is cholesterol ester. What is cholesterol ester? Cholesterol is esterified with fatty acid. We have a third enzyme from the pancreas which is called cholesterol esterase, separates fatty acid from cholesterol ester, and then we get free cholesterol. Okay? After complete digestion of lipids, all lipids are converted into glycerol, monoacyl glycerol at position number 2, monoacyl glycerol at position number 6, lysophospholipid. These are products of digestion, cholesterol. All these things are emulsified with bile salts and make myocells. Myocells, I don't know a synonym in English. Myocells, if we get an oil and add a drop of soap, you will get a myocell. A myocell is a liquid which has white color, emulsified lipids, water-soluble lipids. If we add bile salts to the product of digestion of lipids, lipids will be emulsified, and then lipids will be translocated from the lumen of the intestine to the intestinal cells. We are now in the lumen of the intestine, inside the lumen of the intestine, and then we are translocated to the wall of the intestine. The wall contains cells, cells of the wall of the intestine or the small intestine. Okay, so myocells are translocated from the lumen to go to the wall of the intestine. What will happen in the wall of the intestine? The wall of the intestine contains the mucosal cell. Mucosal cells are found in the wall of the intestine. If you take histology, we have another type of cell which is called serosal cells or basal cells. We have different types of cells in the wall of the intestine. Inside the mucosal cell, the mucosa will sensitize chylomicron. Of course, the structure of the chylomicron you are going to study in detail in the course of lipid metabolism. What is chylomicron? These are particle, spherical particle, okay, like a sphere, which contains lipids, containing triglycerides, cholesterol esters, phospholipids, all types of lipids surrounded with a protein. Why we should do this? Why we should make a particle surrounded by a protein? The core is lipid, and outside the core there is a protein to make it water soluble so that it can go to the bloodstream. The last thing I will discuss today is disorders, a disease of lipid digestion and absorption. This is a famous disease which is called steatorrhea. What is steatorrhea? Excessive amount of fats lost in the stool. Lipids are not digested and they are going to be lost in the stools, and the stool will look white color because it contains excess amount of lipids. Okay? Do you hear me, please?
Yes.
Yes, doctor.
Deficiency of pancreatic lipase. If there is disease in the intestine, cancer of the pancreas, or any inflammation of the pancreas called pancreatitis, there will be no lipase. So there will be no digestion of lipid. This is a dangerous condition because the body cannot absorb fat-soluble vitamins. Fat-soluble vitamins needs pancreatic lipase to be absorbed. If there is a disease in the pancreas, obstruction by a stone, cancer of the pancreas, inflammation of the pancreas, all these, pancreatitis means inflammation. There will be no lipase. There will be no digestion of lipids, and lipids are lost in the stool. There may be another cause, diseases of the liver, no bile, because the bile are sensitized by the liver. The liver may have hepatitis. Hepatitis means inflammation of the liver cell. Or stones, biliary stones. There is a stone in the bile duct and there is obstruction, and the bile is not secreted in the intestine. Without the bile, the lipids will not be absorbed. A third cause, a disease of the intestinal cells. As I said again, there is a cell in the wall of the intestine. There are some diseases in the intestinal cells or the intestinal epithelium. As a result, lipids are not absorbed and go to the blood. They are digested, but the wall of the intestine cannot absorb lipid from the lumen and translocate it to the blood. The end result will be loss of the body weight and deficiency of essential fatty acids. These lead to certain diseases. You are going to study in metabolism what are the symptoms of essential fatty acid deficiency and deficiency of fat-soluble vitamins. I will stop here, and then Dr. Riham will complete with you from fate of absorbed lipids. Anyone want to ask me any question, please? Anyone want to ask any question? Is everything clear? Please answer me.
Yes, doctor.
Okay, I'm going to stop here and then make an appointment with Dr. Riham by the WhatsApp group to give you a lecture next Monday. Okay? Give her a suitable time for you so that she will come and...
Doctor, I have spoke with her. He said even this week, because next week we are going to, we have an exam on 20th. If you said next week, definitely it's close to our exam. Why not this week, if not possible?
It's not possible to get a lecture this week?
Yeah, we're supposed to have it this week.
You are supposed not to come this week?
We're supposed to have a lecture within this week, several lectures, because we are now close to 20th of December.
You need more lectures, I understand. You need more?
Yeah.
She will give you 4 hours.
Close to the
okay, she will give you 4 hours. 2 lectures, every lecture by 2 hours. This is too much.
How about yours, online lecture?
You need online? You don't want to attend? You need to stay at home? You need to stay at home?
No. I said we have to combine both two, online so also face to face, because we have
Okay, I will give you online. I will give you online to finish protein metabolism. If you finish lipid metabolism with Dr. Reham, I will finish protein metabolism with you, and you attend amino acid metabolism with me. I'm going to finish amino acid next Wednesday. So you will attend with me general amino acid metabolism. I give you Zoom meeting on general amino acid. So most metabolism are going to be finished. Dr. Reham will finish lipid metabolism, and I will finish with you protein metabolism. So the majority will be covered. You are left only with chemistry, and chemistry is easy. I can make a record for you for the lectures of chemistry, so you can catch up. Chemistry is much easier than metabolism. Okay? I will finish with you protein metabolism this week, and you will finish lipid metabolism with Dr. Reham, so there will be no problem. You will take 4 hours with Dr. Reham, and with me additional 2 lectures this week. Okay?
Okay. Thank you.
Okay. I'm going to leave now. Thank you very much. If anyone has question, please write it down. If we don't, if I can't give you any lecture, I will send you a record, a video record for the lecture, so you can hear it. Okay? Someone asked me about the vitamins. I will give you a record about the vitamins, so you can catch up rapidly. Okay? Thank you very much. And I'm going to leave now. Goodbye. Goodbye.
Goodbye. God bless you.
Okay, thank you.